Ever notice how you just kind of take for granted, like, the ground you walk on?
Mm-hmm.
Sidewalks,
Yeah,
buildings,
yeah,
bridges,
yeah.
all concrete, right?
Right.
But how much do we really know about how that stuff gets made?
Yeah.
Today, we're going on a journey to uncover the surprisingly intricate world of cement production.
And it is surprisingly intricate.
Yeah.
Most people don't realize it's a whole process, almost like baking a giant rock-hard cake.
With a recipe list that's way less delicious.
Right.
We're talking limestone, laterite, shale ingredients you'd expect in a geology textbook, not your driveway.
What's fascinating here is that despite the exotic-sounding names, these are actually some of the most common materials on Earth. Limestone, for example, is key because it's largely made up of calcium carbonate, the bedrock of our cement-making adventure.
Okay, so we're starting with a mountain of rocks. What's next? Just toss them in a giant blender.
Not quite a blender, but there is a lot of breaking down involved. Think blasting, crushing, grinding these initial steps. Turn those massive rocks into a more manageable powder.
Okay.
The video actually mentions piles of this stuff weighing up to 1,000 metric tons.
1,000 metric tons.
Yeah.
It's like 1,000 small cars, all ground up. At that scale, it's hard to imagine precision matters, but does the size of those particles actually affect the final product?
Absolutely.
Really?
It's all about surface area. Imagine trying to dissolve sugar cubes versus granulated sugar. The finer particles react faster.
Right.
It's the same with cement. Smaller particles mean more surface area for chemical reactions later in the process, which ultimately determines the strength of the concrete.
So it's like each grain of rock is a tiny ingredient waiting to be activated.
Yeah.
This is way more intricate than I ever imagined. But we've got our powder now.
Okay.
What happens next? Where does the heat come in that I hear so much about?
This is where we enter the inferno. Picture a massive oven called a kiln, reaching a scorching 1,600 degrees Celsius. To put that in perspective, that's hot enough to melt most metals.
Okay, 1,600 degrees, definitely not your grandma's oven.
No!
What's happening to our rock powder in this intense heat?
This is where that calcium carbonate we talked about earlier takes center stage. The intense heat actually breaks down its chemical structure in a process called thermal decomposition. Don't worry too much about the technical term. Just know that this breakdown releases carbon dioxide and leaves behind calcium oxide, also known as quicklime.
Quicklime sounds a bit more exciting than plain old calcium oxide, doesn't it?
It does.
But is this where we get our actual cement?
Well,
Or are there more transformations to come?
we're getting close.
Okay.
That quicklime, along with other elements from the raw materials, undergoes another transformation in the kiln's heat, fusing together to create a new material.
Clinker. Clinker, that sounds less like a building block and more like, well, the sound a rock makes when you drop it.
Yeah.
What's so special about clinker?
Think of clinker as the superhero of this story.
Okay.
It's the intermediary stage between raw materials and the final cement.
Now, clinker's properties, like its mineral composition and hardness, directly influence the final cement's strength and durability.
So those initial steps, from carefully crushing the rocks to that inferno in the kiln, it's all about creating this crucial clinker.
Precisely. The entire process is a delicate dance of temperature and timing, all leading up to this crucial stage where clinker emerges as the star player.
Now, this is what I call a deep dive. We've gone from boring old concrete to blasting rocks and creating super strong clinker in just a few minutes.
I like it.
But what happens next? How do we get from this clinker to the bags of cement we see at construction sites?
Yeah.
We'll uncover those secrets right after this quick break. So we're back,
Again.
and our journey through the world of cement making continues.
Yes, it does.
We've just witnessed the birth of clinker.
We have that unsung hero of construction.
Indeed.
So what's next for these tough little nuggets?
Huh.
Back to the rock crusher for round 2.
You know the drill.
Mm-hmm.
The clinker does get another round of grinding, but this time it's all about precision.
Okay.
We're talking about pulverizing it down to a superfine powder with particles measured in microns.
Microns.
Yeah.
That's even smaller than I can picture.
It's tiny.
Why is that level of fineness so important at this stage?
Remember how we talked about surface area earlier?
Uh-huh.
The same principle applies here.
Okay.
The finer the cement powder, the more surface area it has to react with water when mixed.
Right.
This means a stronger, more durable final product.
Okay.
It's like the difference between shaking hands and giving a full hug.
Okay.
The more contact, the stronger the bond.
Okay, that analogy definitely helps. So we've gone from massive rocks to super fine powder.
We have.
Are we looking at cement yet, or are there more surprises in store for us?
We're almost there.
Yeah.
But like any good recipe,
Yeah.
cement needs a touch of finesse.
Okay.
At this stage, they add a pinch of gypsum to the mix.
Gypsum, like the stuff used for drywall?
That's the one.
What's that doing in my cement?
It might seem out of place, but gypsum plays a crucial role.
Okay.
It acts as a setting regulator,
Okay.
preventing the cement from hardening too quickly.
Oh, okay.
Without gypsum, your concrete would set almost instantly,
Yeah.
leaving construction workers scrambling to finish before it turns rock solid.
So gypsum is like the patient friend that keeps the cement from jumping the gun.
Exactly.
I never would have guessed it was such a crucial ingredient.
It's important stuff.
But we've got our super fine powder,
Yeah.
our perfectly timed gypsum. This has got to be the home stretch, right?
It is.
What happens next?
You're right. We're in the final stages now.
Hmm.
The finished cement is stored in massive silos, ready to be packed and shipped to construction sites around the world.
Wow.
And this is where things get interesting, because we're not just talking about one type of cement.
Right.
Remember those acronyms from the video, OPC and PPC?
Yes. OPC and PPC. It's like the secret code of construction. What's the difference between these two cement celebrities?
Think of it like choosing the right tool for the job.
Okay.
Ordinary Portland cement, or OPC, is your workhorse.
Okay.
Reliable, strong, and perfect for most everyday construction projects.
Okay.
But then we have Portland Pozzolana cement,
Right.
or PPC. This one has a secret weapon.
Okay.
Fly ash.
Fly ash. Doesn't sound like something I want in my building materials.
Right.
What is that exactly?
It's actually a byproduct of coal combustion.
Okay.
And before you dismiss it, fly ash has some pretty amazing properties.
Okay.
Adding it to cement creates PPC, which requires less water, releases less heat while curing, and boasts greater long-term strength and durability compared to standard OPC.
So PPC is like the eco-conscious overachiever of the cement world.
In a
I
way.
had no idea there were such subtle differences in these powders.
Yeah.
But how does anyone keep track of it all?
Well,
Do those bags at the construction site have some kind of secret labeling system?
you bet they do.
Well,
Quality control and branding are paramount at this stage.
okay.
Every bag is carefully labeled, ensuring it contains the correct type of cement with consistent properties.
Right.
All vital information for engineers and construction workers.
It's amazing to think about all the hidden complexities behind a material we take for granted every day.
It really is.
But we're not quite finished with our cement journey yet, are we?
Not quite.
What happens once those bags reach their final destination? What's the big picture here?
That's the million-dollar question. We've explored the fascinating, intricate process of making cement, but it's just the beginning.
Okay.
What's equally important,
Yeah.
and what we'll delve into next, is the environmental impact of this global industry.
We've journeyed from mountains of rock to microscopic particles, all in pursuit of understanding this ubiquitous building block,
Yeah.
cement.
Pretty amazing.
But as you mentioned, there's a bigger picture here. And it's not just about skyscrapers and sidewalks.
Yeah.
It's about the planet we call home.
Exactly. The truth is, as fascinating as the cement-making process is, it comes with an environmental price tag.
Okay.
Remember that thermal decomposition happening in the kiln?
Yeah.
That releases a significant amount of carbon dioxide into the atmosphere.
Right, because we're breaking down calcium carbonate, and carbon dioxide is a byproduct.
Right.
It's like the flip side to plants absorbing CO2, isn't it?
Precisely. And on a global scale, cement production accounts for a surprisingly large chunk of human-caused CO2 emissions.
Wow.
It's a major contributor to the very real challenges we face with climate change.
Yeah, that puts a whole new spin on those concrete jungles we see everywhere.
It does.
It's easy to appreciate the convenience and durability of concrete. Sure.
But less so when you consider the environmental impact.
It's a classic case of what we call embodied energy.
Okay.
The total energy consumed throughout a product's life cycle,
Right.
from mining raw materials to manufacturing and transportation.
Right.
And with cement, that embodied energy is significant.
So what can be done? Are we destined to keep building a less sustainable future, one concrete slab at a time?
Not necessarily. There's a lot of exciting research and innovation happening in the world of sustainable construction.
Okay.
Some companies are experimenting with alternative materials, things like geopolymer cement or even cement made with captured carbon dioxide.
Wait, so using CO2 as an ingredient instead of releasing it? That sounds almost too good to be true.
It's still early days, but the potential is there.
Other innovations focus on reducing the energy consumption of the traditional cement-making process, making it more efficient and less polluting.
That's encouraging. So it's not about abandoning concrete altogether,
Right.
but rather finding smarter, more sustainable ways to produce and utilize this essential material.
Exactly. This deep dive into cement has taken us from massive kilns to microscopic particles and now to a global challenge.
Right.
It's a reminder that even the most commonplace materials have hidden depths, impacting our world in ways we might not always see.
It's a powerful thought, really. Next time I walk past a concrete building, I'll be seeing it in a whole new light.
Yeah.
I'll be thinking about those limestone hills, the fiery kilns, and the quest for a greener future for this surprisingly complex material.
It's amazing, isn't it?
Yeah. Thanks for joining us on this fascinating journey. Until next time, keep exploring, keep questioning, and keep those deep dives going.